Hello everyone. Welcome to the last workshop of Skills Future Festival at NUS. My name is Alifa and I will be your MC for today. As part of the Future Works team, we are been exploring not only the skills and technologies shaping tomorrow's workplaces, but also the core values, and sustainability is certainly one of them. What Our final workshop invites experts from Singapore Polytechnic to share their experience and strategies on how you can reduce energy use, improve efficiency, and drive sustainable change in your environment. May I introduce Senior Lecturer Mr. Saw Tun and Adjunct Lecturer Mr. Ahmad Sulaiman, who also holds the role of Educational and Experiential Opportunities Assistant at Singapore Polytechnic. Mr. Saw Tun, Mr. Ahmad, over to you to share your slides, please.
Thank you. Good afternoon, everyone. My name is Soton. I'm a senior lecturer, I introduced before, from the Mechanical School of Mechanical and Aeronautical Engineering, Singapore Polytechnic. I also oversee one of our continuing education training CET program, Specialist Diploma in Air Conditioning and Energy Sustainability. In addition, I have developed short courses on MEP, Mechanical, Electrical, Plumbing, Building Information Modeling, BIM applications for the built environment sectors. Within MAE School, I lead the Energy and Sustainability Focus Group. Today, I'm joined by my colleague and adjunct lecturer, Mr. Ahmad Sulaiman, as we share some of our insights and experience from our MAE sustainability journey at our workshops. To share our sustainability journey, first of all, I would like to highlight what are the key motivations that lead us to embark on this path. First of all, GreenGov SG has sustainability targets for public sectors. This table lists down the targets for public sectors for greenhouse gas emissions, energy, water, and waste. As one of the IHL in SG, we try to align SG GreenGov initiatives, such as meeting the sustainability targets and to be the influence and enabler of these green efforts. In SB level, we also have our own sustainability targets, such as 60-30 visions. We have set FY 2022 as the baseline year for our Scope 1 and Scope 2 greenhouse gas emissions, and we aim to reduce these emissions by 60% by FY 2030. On top of that, we also launched the 5% challenge, which aims to encourage our staff to reduce electricity consumptions through behavioral and operational changes that are not reliant on infrastructure upgrades. We also aim to reduce the waste disposal index and water efficiency index by 30% and 10% respectively by 2030. Another key motivation is the growing importance of sustainability as the major industry trend. Notable developments include the introductions of carbon taxes and mandatory sustainability disclosures for Scope 1 and Scope 2 emissions for all the listed companies, and followed by Scope 3 disclosure expected to be by 2026. As educators, we believe it is essential to equip our students and learners with the necessary skills in these areas. At the same time, we aim to work alongside with our industry partners in their sustainability journey as well. MAE sustainability journey for the workshops can be split into 3 phases. Phase 1, build capabilities. Phase 2, planning and baselining. Phase 3, implement and improve. Under the step 1 of build capabilities, with the support of the school management, we have carried out 3 key initiatives. We assign a dedicated team to lead our sustainability efforts. We strengthen our internal competencies and capabilities by attending relevant courses and acquiring new knowledge and skills in the area of sustainability. We engage with industry stakeholders and solution providers to stay aligned with the latest industry trends and sustainability solutions. As part of our phase 2 planning and baselining, we choose to focus on improving the energy performance of our workshop W1411 and W1412B. We try to conduct the energy audit and we try to baseline the energy consumption first. Establishing the energy baseline is the crucial first step before pursuing sustainability improvements. To achieve this, we conducted a level 2 energy audit to analyze energy consumption patterns and identify potential energy saving opportunities. The energy audit allowed us to establish the baseline and identify the breakdown of energy consumption. This is our findings from the audit. As expected, air conditioning accounted for the largest share, consuming over 70% of the total energy at the workshops. Now I would like to analyze a little bit further into the energy consumptions data for the AC system. Before analyzing these findings of the air conditioning's AC systems, I would like to highlight the key equations which is shown here. Key energy consumptions in kilowatt hour is basically energy efficiency in terms of kilowatt per RT multiplies with cooling load in terms of refrigeration time multiplies with the duration times hours. This equation shows that total energy use is determined by two main factors. The first one, energy efficiency and cooling load. Understanding this relationship is crucial for identifying the effective strategies to reduce energy consumptions. Based on the audit finding of the air conditioning system, we carry out a more detailed analysis to pinpoint the specific areas where energy performance could be improved. We observed that energy efficiency was relatively acceptable for this finding. The energy efficiency of the equipment has 0.964 kilowatt per RT. However, the cooling load intensity, as shown in this table, was particularly high at 18.07 meters squared per RT. Since energy consumption is influenced by both energy efficiency and cooling load, as illustrated and explained in the equations, it is clear that for this particular case, reducing the cooling load presents the most effective opportunity for lowering the overall energy use of these workshops. The audit identifies several potential energy saving opportunities. This is the potential opportunity that we can save energy, as summarized in the table. Through the behavioral and operational adjustment, we aim to reduce the air conditioning energy consumptions up to 24.49%. The audit also recommended replacing existing lighting with energy efficient lighting fixtures to reduce the energy consumptions from the lighting as well. Additionally, operational improvements in the compressed air systems are expected to contribute further energy saving. In total, the projected energy saving across these main facility systems amount to approximately 29%. This is our finding and projected opportunity. Another initiative that we did, in addition to conducting the energy audit, we also implemented the energy monitoring system in the workshops. This system enables us to collect energy data for evaluating the effectiveness of energy efficiency measures and to continuously monitor the performance of key systems. This is the dashboard that we install for the energy monitoring system, which allows us to monitor the real-time energy usage of our workshops. Now I'd like to move on to the phase 3, which is implement and improve. In this phase, we prioritize and implement the sustainability measures as recommended by the audit based on the audit findings and recommendations. We select two systems. The first one for the AC systems. For the W1411, we try to operate half of the VRV fan coil units to stretch our cooling load intensity from 18 meters square per RT to around 30 to 40 meters square per RT. Similarly, for the W1412, we also only operate half of the VRV fan coil units during peak periods and only one fan coil unit during off-peak periods. For the compressed air system, we changed the operational pressure from 8 bars to 6 bars. Next slide, I would like to share our result of the findings for the past 3 months. Since January 2025, we have implemented these energy-saving measures in our workshops. By comparing 3 months data before and after the implementations, we observe a 28% reductions in energy consumptions for the air conditioning systems achieved through the behavioral and operational changes. Similarly, the compressed air system saw 24% reductions by lowering the operation pressure from 8 bars to 6 bars. Overall, for the 3 months, we managed to save the energy of more than 8,600 kilowatt hours. I also would like to share here another energy-saving initiative that we carry out in our refrigeration and air conditioning lab as well. We replaced our old air handling systems with a new energy efficient system. This upgrade to the airside system significantly improved the lab energy performance. This table shows and compare the energy usage of the airside system before and after the upgrade. I would like to highlight the same equation again here. I would like to highlight the 2 key factors again here: equipment efficiency and cooling load. In our case, for this upgrade, only the airside system is upgraded and there are no change to the water side of the air conditioning system. As a result, overall system efficiency actually did not improve. In fact, it has declined. This reinforces an important point here. When evaluating the energy consumptions of AC systems, we must consider not only equipment efficiency, but also cooling load. By applying the right control strategies, we successfully reduce the cooling load from 20 RT to 3.5 RT here. This resulted in a substantial drop in energy consumptions by about 20 kilowatt hour per day, achieving over 60 to 70% energy saving from airside alone. In summary, the airside system upgrade has resulted in over 16% of energy saving. There is also a strong potential for further reductions on the water side, specifically through the use of variable speed drives for the chill water pumps, condenser water pumps, and cooling towers. With this additional enhancement, we aim to achieve total energy saving of over 40% for this lab in future. Now, I would like to take a moment to reflect on why we embark on a sustainability journey again. First and foremost, as educator, we strongly believe that it is our responsibility to equip our students and learners with the skills, knowledge, mindsets necessary to thrive in a rapidly evolving world, one where sustainability is no longer optional but essential. At the same time, we recognize the importance of working hand in hand with our industry collaborators to work alongside with them as they navigate their own sustainability transitions, sharing knowledge with them co-developing solutions, and learning together. Now, I would like to share our CET courses available for industry adult learners in the areas of sustainability. The first one that we have here, I'm also a course manager for this course, Specialist Diploma in Air Conditioning and Energy Sustainability. It is a one-year program and targeted the industry learners from the built environment industry. It has two PDC module, post-diploma certificate module, two PDC, post-diploma certificates. Under each certificate, we have two modules each. For example, the first PDC, Air Conditioning and Energy Sustainability, has two modules, Air Conditioning Systems, Green Mark, and Energy Sustainability. The second PDC is about Energy Modeling and Management. Under this PDC, we have two modules as well, Integrated Building Management Systems and Information and Energy Modeling of Facility. Another specialist diploma related to the sustainability is the called Sustainability Specialist Diploma in Sustainable Digital Manufacturing. It is also similar to the first one. It is one-year program, and it is a newly launched program. We're going to start the course in coming semester. It has two PDC as well. The first one, Manufacturing Digitalizations, got two modules. The first module, AI-driven data analytics for sustainable manufacturing. Second module, Essential of Advanced Manufacturing. The second PDC is called Monitoring and Reporting for Sustainability. It also had two modules, Sustainability Reporting and Strategies, Energy Monitoring and Auditing. On top of specialist diploma that we also have short courses in the areas of sustainability. Driving sustainability in manufacturing through ISO 50000 energy management approach and performing fundamental greenhouse gas accounting based on ISO 14064, a manufacturing perspective. These two courses are co-developed with TUSU. Another short course that we have, Sustainability Roadmap Implementations for Manufacturing Industry. This course was co-developed with SMF. Beside all this, we also have another course, Transforming Towards Sustainable Manufacturing Program, jointly developed with the SP and HP. Program benefits include foundations of sustainable manufacturing, structure implementations, and practical applications. There are three phases. In the phase one, 2-day business needs analysis workshops in SP. In phase two, there will be 4 hours proof of concept monitoring program by the HP, and followed by the phase three, evaluation and implementation. With that, I would like to end my presentations. Now, I would like to pass on to my colleague, Mr. Ahmad Sulaiman. He is the adjunct lecturer with us, School of Mechanical Aeronautical Engineering, Singapore Polytechnic. He is a practicing EOA, BCA practicing EOA, and has over 40 years experience in the field of air conditioning and energy auditing, and he holds 2 patents on data analytics as well. He has very rich experience in the field of energy monitoring and air conditioning. He will be sharing his insights and experience collected over the 40 years. Mr. Ahmad, please.
Yeah, okay. Hi. My name is Ahmad. I think I don't have to introduce myself. Saltun has already introduced me. I think that's more than enough. Okay, Saltun, next. So basically, over the years, what we have learned is when we start off with the energy saving program way back in 2000, there's a lot of misconception. All right. One of the issue we faced was whenever a building owner want to save energy, they always look for the electrical engineer, which is quite common. Because you want to save energy, you go to the electrical engineers. But in the initial years, when we do all these audit, you know, the electrical engineers basically look at the end result. What to do, they may not have any idea because the power usage is the result of certain action that need to be taken. And because of this conception, there's a lot of failure in the initial start. All right. So as a result, a lot of people do not really believe that energy saving could be done because everybody thought was they've tried it and the result never shows. All right. As a result, it seemed like this industry is like a BS, you know. So this is the issue that we first face when we first start off early 2000. All right. So that's why when we do the energy audit over time, while the objective is to save energy, but to saving energy, that is not the primary objective. I always told my colleague and my team, our first objective is always inside the space. Getting the space right, all right, that's very important. Because if you just want to save energy, then actually it becomes very easy. You just switch off your aircon, you save energy already. All right. But air conditioning in the building is not about energy saving. It's providing comfort so that you can operate or you can do your own production or do your work in a much more productive manner. You know, our founding father, LKY, he was only, I mean, in the last century, he was saying that air conditioning was one of the best invention because it allows him to operate, all right, or be productive over a long period of time because of the condition that he has within his office. All right. We are not living in a temperate climate where our temperature is like 15 degrees, 50% RH. We are living in Singapore where our weather is the tropic, hot and humid. So if we are working without air conditioning, while we still can work, it do not give us the production or the productivity that we want. So that's why if you look at all the building in Singapore, most of them are air conditioned. And because they are air conditioning, they are air conditioning this building. The main power guzzler in all these buildings are air conditioning. Right? I was lucky that in the initial years, when I do my mechanical engineering, I opt for space cooling, which is air conditioning. And we have very few courses in Singapore. And from my own experience, I learned air conditioning through the experience that I gained with with the OEM or original equipment manufacturer. From there, then you build up. All right. So that's why environment sustainability or energy saving or energy efficiency cannot be done in isolation. You just cannot focus on the end result. All right. It's just like when you are going for an exam. Yes, you want to pass the exam, but you cannot just think about the exam. You have to learn and understand the topics. All right. Then you can so-called do well in the exam. It's something like that. The end result is your secondary objective. The primary objective is still the what you need to do. Okay. So Sotun, next. Sotun?
Yes, may I?
Yeah, next. Yeah. So that's why, like what Sotun say, it's very important for us when we want to do any energy saving initiative. All right, we need to prioritize your priority first. All right, make sure you get the inbuilt environment correct, and then you optimize your system. So then people were saying, oh, everybody was looking at efficiency, like what Sotun is saying just now. All right, when we do our so-called audit, we are not totally focused on energy saving first. We are looking at how does the condition that we want within the space, are we getting the correct condition, or are we actually using a lot of energy in that example that Sotun tell you earlier? The saving is actually reducing the amount of cooling load that you want, that you are using, rather than the energy saving itself. All right. One of the things we find out was because of our so-called our objective of we wanted to cool the space within a certain temperature and RH, we actually overcool the space. All right. And because you are overcooling the space, all right, as a result, during the audit, we found that yes, our efficiency is good, but then our condition within the space is not what we want. I mean, we have the temperature, but the RH was not the one that we want. The RH was a bit wet, I think about 70, 75%. whereby we want it to be below 70% so that we can protect the equipment, especially in the after hours where your load is very low and there's no occupant, you know, but we still need to maintain the machine humidity so that the machine can last long, you know. So during this time, when we design the air conditioning, we only design at peak load. We call it peak load. We design when the machine will operate where the occupancy is at the highest on a hot day, you know, and all the activity is at its peak. But when we do the actual operation over a period of time, 24-hour window, you can find that the peak period may be between 9 to 5. After that, you have a lower operation, and then at night, there's no operation, but you still need to maintain the machine. So as a result, during that period from 9 p.m. to the next day 9 a.m., which is about 12 hours, actually there's no load, all right? Because all the machine are not working, but you still need to maintain the condition because you need to maintain the machine. So at this type of situation or environment, how do you operate this air conditioning system? So this is the question that we need to ask. All right. So that's why in the air conditioning field, I think Sultan already elaborate. All right. We have like about 5 opportunity area that we can work on. It's not only about efficiency. The first one is like what Sultan say is the intensity of load. How much cooling load are you using for that particular space? All right. Okay. So first opportunity we ask is, can we reduce the aircon area? So, all right. So if during the day you may use like 2 or 3 rooms, but during the night, if you can collate all the equipment that need to be conditioned, you put it into a smaller room, then your area becomes smaller. That is also an opportunity. The second is like what Sotum say is the intensity. And this is where a lot of people do not apparently they feel that they don't have controls. All right. But from my experience, this is the main thing because if you can reduce the amount of cooling per square area, all right, what this intensity is something like a computer power. In the computing world, the better computer will be the one with the higher power per square per smaller area. That means how much byte per small area. But in the air conditioning field, ours is the other way around. We are talking about how much cooling can I put in the biggest area. All right. So it's the opposite. Right. But the meaning is still the same. If I can increase my area of cooling, all right, and I still use 1 ton of cooling, that means I save quite a number of energy or kilowatts. All right. So this is important because this is where a lot of industry miss it. BCA do not miss it. They have their so-called benchmark. All right, but in our so-called working environment, this cooling load intensity was always been overlooked. Right, the most popular parameters of metrics is the efficiency. Everybody knows about it, which is kilowatt per ton. All right, because the focus has always been kilowatt per ton. All right, this is one of the opportunities that you can work. But before you work on the kilowatt per ton, the cooling load intensity is the first one that you need to address. Once you have a very lean cooling load intensity, then you work on your efficiency, right? Then you have like about double, double the saving that you can get. All right. The fourth one will be the how long are you operating your plant? All right. So if the plant is not operating, push everything down, but maintain a certain skeletal condition so that you can have the condition maintained for you to protect the equipment of the machine. And the last one is we talk about your tariff. So this one is again is not a skill, but it's more like how do you negotiate with the power vendor? All right. If you can negotiate lower, eventually the cost of you using the electrical right become even smaller. All right. That's where you can save. So these are the 5 opportunities that we should look in totality. All right, we don't just focus on efficiency. Okay, but again, remember my first takeout. Prioritize your requirement. The space condition will be first, followed by the efficiency or the energy saving. Okay, next topic. Okay, so again, this is just a repeat, the concept of energy saving. All right. Okay, at the end of the day, when we talk about energy saving, I touched earlier when we start off with the energy saving industries way back in the 2000, all right, we always have a lot of failure. All right. Mechanical engineer, electrical engineer can come up with a lot of computation saying that you save this, you save that. All right. But the most important, all right, after all the computation is done, we need to see the real saving. That's why one of the things that I always ask my team is whatever computation that you have done, eventually, all right, your computation can be okay or not okay until the finance director, all right, feel that he has saved energy, or that means the amount of money that he pays for his utility for that month reduce. All right, if you are doing like the tengah issue whereby people say you say energy saving, but then how come I still pay like double, you know? So that means in term of your accuracy, in term of your implementation, something is not right. All right. So the final litmus test will be when the group financial director or the housewife can come to you and say, thank you. Yes, I paid lesser utility for this month or this year. That will be the one that really tested your calculation, your initiative, whether you really do it or not. All right. So that's why it's very important that you get your priorities right. Because remember, we as auditors or we as engineers, we will do all the so-called analysis and implementation. At the end of the day, the guy who operate your plant is not you or is not us. Is the facility guy. You know, the facility guy who operate the plant, his objective is not energy saving. All right, his objective is to make sure that he has less complaint. So the moment you get out of the plant room, he will take over that plant. If you don't address your priority right, you get out of the plant room, he will operate the plant so that he can address his immediate problem, which is less complaint. Right? The housewife don't complain, the finance director do not complain, and the business can excel. You know, all right. Then only he can look, because once he stabilized and all his operation objective are met, then we can talk about your so-called energy efficiency, how much you are saving and all that. Because remember, all this air conditioning that you do to a building is to facilitate the business of that building. Whether is it a hotel, is a retail mall, or even hospital, or even manufacturing plant. All right. That is their so-called objective of why the building is being built in the first place. Okay. So your secondary objective may be important to you, but it's not the primary objective. Okay. So when you operate on this primary objective, as a secondary objective, the most important thing is the guy, once he stabilizes his so-called operational condition, then he will need to know, then he will go to the next level whereby he need to know how much load is he doing now. All right. And compare against what is his optimal. So every single hour operation, then he got time to so-called analyze and improve his performance. All right. Because if you don't address the primary objective, the secondary objective will just be down the drain. All right. And then once you get these two objectives right, your final test will be the monthly bill. All right. If you do your calculation right, you do your operation right, and all your numbers click, all right, you should see this saving inside your bill. Okay. So we should not give any reason why we don't get the final objective, but we should find where are the areas that we need to improve. Go to next. Sultan?
Wait, yes, wait. S-
Okay, so very important. That's why one of the issues we face is how do you want to cut your cooling load intensity? cooling load intensity in any air conditioning system is the chill water plant is the supply side, right? That means if there's no demand, there's no supply. The most important thing of improving your cooling load intensity is your air side. Right? When we say the air side, we are talking about the AHU, PHU, and the design of the controls for the air side. Right? Because the air side is always the demand side. Okay. So if your air side is not running, you can't operate your chiller plant. All right, because there's no load. Only if the air side is running, then you can operate your chiller plant. That's why in our journey here, we are focusing on the air side because the air side may look simple, but you need to have a lot of imagination to address your air side. Okay? So that's why it's important that when you are doing your air side, when we were doing the upgrading of the AHU, we need to understand what is our psychometric plan. All right, that's why in one of our so-called course, we actually inform our student how do you look at your psychometric plan. Once you understand the psychometric plan, then how do you set up? Because a lot of time I see on the ground is the plan and the setup do not sync. All right. One of the issues that we always face is humidity, but we don't have a humidity controls. And this is one of the reason why we have this issue of high humidity, moldy issue, because our control is only based on temperature. Right? While humidity is one of the objective of your design, but there is no control for it. Okay. And now we put in CO2 concentration, right? Air change. All right. All these control so-called in sync. That means they are integrated such that if there's a change in condition, they will work automatically. And then finally, we are talking about air side efficiency. How do you measure the air side efficiency? All right. So that's why if you notice, the setting up of this air site become very important. Not only you design, you need to set up. After you set up correctly, then you need to put the control in. Why the control is important? Because this control will be used by your facility or your operation guy to operate this so-called AHU or PHU. If you don't have the control, how you want to operate, because most of the control that I saw on the air side is there's no humidity control. Everybody assume that it's going to be there, you know, and that's the issue. All right. So when you don't have control, you can't so-called address your humidity issue, but you expect the technician on the ground to do it. All right. I think it's not fair for them because they just take what you design. Right? It's just like, you're driving a car, but your own car don't have an overdrive. But then you ask him to operate an overdrive. Yes, he can do it. He just ram the whole thing up. So this is one of the issues that we face. You want people to control, but you never set up the control such that the operator, which don't understand how the system is being designed, he don't have that futures to control your condition that you want. All right. And then the last one is we need to monitor, track, and deliver. So while you put in your plan, you install, you have the control. The last part is you need to monitor whether whatever system that you put up, you deliver what you're supposed to deliver. That means temperature, RH, humidity, CO2. And lastly is the air side efficiency, which is an issue in our industry. So to next. So to, yeah, next. So this is where we always tell okay, if you look at this slide, on the left side is basically, I think you missed one slide. Can you go back one slide? Yeah, this one. So when you see, the issue in our industry is we have the existing, we have the object, we have the proposed. Okay? The existing is, the plan is always good, temperature, RH, CO2. All right? The specification is also good because the specification also address the temperature, RH, and CO2. The only problem is the setup. If you look on the left side, you see, you only have one written sensing to control the FCU or AHU, but you need to control 3 conditions. All right. So as a result, when you operate based on the left side setup, you will get those kind of curve, whereby the temperature is good, but the RH keep on going up and down. All right. And this is common to a lot of hotels in Singapore. All right. Because your setup is not right, so you don't expect to get the correct relative humidity. All right. And this is an issue in our industry. And then when people say, why you don't change? Oh, we've been using it for the last 10 years. All right. I've been in this industry for the last 40 years. That's why I'm privileged to understand where do we get all our control from. Most of this air conditioning, when I first start off, we learn it from the US because they are the one who invent air conditioning. And most of our control, we adapt based on what they use in the state. That's why we always use the written air sensing. And one of the issue is during that time where people are not that discerning. As long as we got cold, we are more than happy. But now, as your standard of living goes up, now you want temperature, you want RH, you want quality of air, PM 2.5 and all this. So you are much, much more discerning. All right. So now if you have temperature alone is not enough. You want to make sure that your RH is also dry because now you don't want to sweat inside the air conditioning room. So that's why we have to change the way we do things. And this is one of the, I would say, resistance that I face on the ground because they always say, I've been using this for the last 30 years, no problem. Yes, no problem because in the olden time, we are not that discerning about the condition in our room. But now with the green mark, with the requirement that we have right now, where you need to measure temperature, RH, and CO2. And the RH is not like sometimes you get, sometimes you don't get. It must be consistent throughout the day. That's why if you look on the right side, we have the temperature control, we have the humidity control, but in the air conditioning world, humidity, we do not control directly. All right, we're using the dew point control because humidity is, if you look at the humidity unit, is in percentage. So it is in relation to a certain number. All right. So if you have a relational number, it's very difficult to control directly. So that's why we always use the dew point temperature. All right. So once you can maintain that dew point temperature, then you look on the right side chart, you have a flat line. That's what you want. All right, so that your room is consistently at 22, 23 degrees. Now they're asking for 25. All right, so you'll be at 25 degrees, your RH must be below 70. So we are talking about 65%. All right, so this is the setup that you need to have in order for you to maintain your humidity. Go to next. All right. And then once you have your humidity, then we talk to about the last objective with the airside efficiency. So once you get your condition in the space right, then we talk about efficiency and we talk about how do you improve your energy usage, energy efficiency. So that's why if your setup is on the left, you can see that as your load come down, your efficiency actually become even worse. Okay. So remember, the air conditioning that was designed for your room is always designed at 100%. But the moment your room already cooled down to about 24 degrees, 20 degrees, the one that you want, your cooling load actually shrink. All right. But the size of the unit never shrink because the physical size of the unit still remain the same. Okay. But as the cooling load reduce, your power need to reduce at the same time. All right. And that's where we say you need to link the power use against your cooling load so that you can maintain your efficiency because efficiency is based on kilowatt per ton, right? Kilowatt is your power, ton is your cooling load. So that's why if you do the setup on the right side, right, because we put all our AHUs on VSDs, now we have EC fan, even better, all right? But the relationship of power is still the same, all right? So as your load reduces, your power also must reduce together. All right, this is the importance of synchronizing your control. All right, so that you maintain efficiency at all times. All right, whether I'm operating at 100% at point two or I'm operating at 40%. So my efficiency will always be improved. All right. The good thing is the relationship when you put the power relationship when you put on VSD, you have the cube rule. That means you have the to the power of three advantage. All right. That actually should improve your so-called efficiency of your plant. So that's why what Sawtun say, even though our efficiency may go up, but because we are using less energy, all right, my total power reduce. Okay, so eventually, but the most important thing I told Sawtun about our SI is we don't have cooling because when we were lecturing at night at 10 o'clock, we feel that the old lab was too cold sometimes, right? So because the lab was too cold, sometimes we shivered. We tried to put on another layer of clothing. But now, after we change, we don't feel that chilling effect anymore. All right. And that is because we prioritize our objective, which is condition against efficiency. Okay. So to next. All right. So, so how do we operate this kind of operation? If you want to, because once you get the result, that's not the end of it. So now, because all our payback or return of investment or payback is measured in term of annual, that means 12 months. All right. So in order for you to operate, because we already handle the space condition, so the operator do not have to worry about meeting the space condition. All right. Then you get them onto the next level, which is the energy cost or the efficiency bandwagon. So we need to teach all these technicians how to look at their cooling load. So you need to understand, while we calculate the load based on annual return, we got to go backtrack into daily cooling load and daily efficiency. All right. And then after daily, you go to hourly. So the technician with the digitization of this SI system, they actually are more skillful. Skillful in the sense that now you have data that come back to you on your operation. So they actually, through training, improve the performance even better than design. All right. All right. If you can operate on a daily basis at certain efficiency and certain cooling load, the final litmus test become very easy because you handle the day-to-day operation very well. All right. You don't have to worry about the year because you are maintaining. And if there's any issue during the course of your operation, you can intervene and address it immediately. All right. That's the best thing about now because now you have data that come back to tell you how good is your operation. In my days, we don't have all this data. That's why when I moved towards from doing air conditioning into energy saving energy services company, when I saw all these data coming back, actually I don't have to assume or we call it aggregation anymore. Because all these data, provided they are accurate, all right, actually enable you to do your own adjustment. All right. That's why if you notice, most of even when we design, we are actually designed at a very conservative level. All right. So for operation, to me, design by right, it should not be an issue because when you do an operation, when you are operating a plant, you have a lot of advantage. All right, based on the environment that you have. But if you understand the data that come back, you actually can improve your performance beyond your design. All right, this is from my own experience. All right. So the final litmus test of looking the saving in the energy bill, if you do it correctly day in, day out, your monthly numbers on your utility should come down. Next, Arthur. All right. So in conclusion is when we do the whole energy audit we have to so-called look it in an overview. That means we look it as in totality. All right, like an ecosystem. People talk about ecosystem. All right. The air side and the water side actually is one complete system. All right. But at the end of the day, when you design build for efficiency, you must always remember who is the real operator. All right. It's not you, the engineers or the designers, but it's the people who do the FM. They are the real operators. All right. So that's why if we actually set up the system correctly, we make the operation very simple. All right. Let's say you have a so-called a set point for temperature, a set point for RH, a set point for CO2, a set point for site efficiency. You just need to toggle all these set points in order to meet your requirement. You get what I mean? All right. Once you have all these features within you, it's easy for the operator to operate. They don't have to assume anymore. All right. And then eventually you will know what's your real time, hourly, daily, weekly, and annual operating efficiency. But do not wait until the end of the week or the end of the month. You should know all these benchmarking numbers, all right, immediately after your operation. All right. All right. At the end of the day, you should consolidate the whole 8 hours or 12 hours of operation. Where are you now? So that the next day, if there's an issue, the next day you can do adjustment. Don't wait for 1 week. All right. For you to recover back, it's going to be very tough. All right. Continuous training on operation. All right. The good thing about our industry is always changing. All right. And therefore, as you operate, all right, I was hoping that you can continuously change your operation for efficiency. All right. Because every building is unique. Okay. So with the data that come back, and this is what we call it about data analytics. The data that come back, you need to use that data for you to improve your performance. All right. Don't just take the data and then say that, data mean knowledge, knowledge mean power, power mean dollar and cents. But if you don't use it, it's just as good as zero. All right. So that's why data analytics become important. All right. If we want to improve the performance, and also it's good for us for our own training. All right. Because now you can judge your operation based on the performance that you have. Okay. And very important is the reporting structure. Your boss must always be inside the whole conversation. Because at the end of the month, he's the one who's going to pay the bill. All right. If he do not care about how much he pay, then at the end of the day, the operator will just forget about it. All right. So that's why the good thing now, most of our building almost digitized. You have data. All right. So now is how do you create these habits? All right, of looking at data and improve your performance day in, day out. Because at the end of the day, your final objective is to improve energy save, to improve cost of operation. I think that's all I want to share. Sultan, okay? I think that's the last one. Yeah.
All right. Thank you once again to our speakers from Singapore Polytechnic for ending the day on such an inspiring and actionable note. And thank you for all of you for spending your Saturdays with us at SkillsFuture Festival at NUS 2025.